Hey, I'm Stephen. I'm showing off the Spark CORTX integration that I created. So CORTX is Seagate's open source large-scale distributed storage platform that has an S3 compatible API. I want to do a Spark integration because I thought once you've got a large-scale data storage, you probably want to extract value from that using data analytics tools. Spark is an open source data processing engine that's used to tackle big data problems. It supports Python, Scala and Java, and it takes a very batteries included approach to do the kinds of things that data scientists would expect, including data manipulation, streaming, machine learning and graph data manipulation. Spark isn't really a niche thing. Taking a look at Spark's webpage shows a number of companies that use Spark for purposes such as machine learning, analytics, and data processing. And taking a look at the companies listed, you realise that some of the problems that they are tackling are probably going to be at a significant scale. When you think back to what CORTX is, large-scale storage, having a data processing engine that is capable of dealing with these large problems is going to be a very useful integration. So taking a step back, Spark is normally considered to be part of a set of big data tools that fall under the Hadoop ecosystem. To oversimplify, one of the parts that Spark normally uses is the Hadoop distributed file system for big data storage, which for this integration will be replaced with CORTX using their S3 compatible API to try and get a native integration. I've set up an Ansible playbook which will run a repeatable set of commands to make it as easy as possible to try out this integration. This playbook is located in the Spark section of the CORTX GitHub integration page. This playbook targets an Ubuntu system and has been tested under Ubuntu 20.04, although it should work on most modern Debian-based systems. For manual installation steps, I've completed a full write-up. It's a bit too long to go through for this video, so if you want to give it a try, then visit the CORTX integrations page on GitHub and search for Spark. So the Hadoop side of the integration allows you to use native Hadoop file system commands to interact with CORTX. The example I show here are listing a subdirectory, adding a directory, and getting a file from CORTX into my local file system. To show off the main goal of this, having Spark integrate natively with CORTX, I've got an example here of loading a file into a PySpark data frame from CORTX. Notice that to do this, I just reference S3A and the path the file is located in without using any external dependencies or requirements to put in my CORTX credentials. So there's one limitation I've found that I can't get around. I can't write files directly to CORTX with Spark as it gives me this header not implemented error. As Hadoop's what's providing the functionality here, it's also got the same issue. The reason for this is there is a component of the S3 API that CORTX does not implement yet, the XAMZ copy source, which Hadoop needs because the upload process is upload a staging file with the copying suffix to CORTX, use the XAMZ copy source to copy this file with the intended name. Until this API is implemented, it's unlikely that we're going to see a full read-write Spark integration. But regardless, being able to take advantage of CORTX's read-only file system is a pretty useful integration.